Well, welcome, Justin. So this is an event all about making Ethereum the settlement layer of Web3, which is, I know, a topic that you're deeply passionate about. I think you're probably one of the most vocal advocates of kind of this future. So maybe just to start, how do you think we're doing? Where do you think we are on this kind of journey towards making Ethereum the settlement layer of Web3?
Right. So there was this meme of Ethereum potentially becoming the internet of value. And as a requirement to get there, you need to be a very solid platform, a very solid home for a lot of assets. And one of the requirements is having very, very high economic security. And so from that perspective, I think the product, I guess, is very, very good. It's very robust. It's about 10 times more economic security than Bitcoin. And I think it is a platform to host potentially trillions, if not tens of trillions of dollars. And we've only just started this journey where now we have about 0.6 trillion, so $600 billion of assets that are settled on Ethereum. And about 8% of that is currently in L2s. So we've seen success both as L1 being a settlement layer, but also directly, but also for rollups on behalf of their users. Yeah.
Amazing. I think this change is happening maybe rather suddenly, perhaps for a lot of people, right? I think with proto-danksharding launching, suddenly, the amount of data availability that exists on the chain has exploded. That hasn't actually been yet fully utilized, I would say, by the L2s. And so we're in this really interesting period where we have all of this excess capacity that we're not fully perhaps putting to work. And that is great for fees, of course, which is really nice. But it also has resulted in a whole debate around whether or not L2s are parasitic to Ethereum. And so I was kind of curious to get your thoughts on this. Are they parasitic? Especially in the context of this big grand vision of making Ethereum settle it all. What do you think?
Right. So if we're just looking at settlement, they're just using the product as is. They're using the very secure safe and putting their assets there. And this is what we want. But if Ethereum is more than just settlement, one of the things that we have is shared composability. And we have all sorts of network effects that are associated with that. And to an extent, yes, maybe like the rollups are parasitic in the sense that they're not growing the pie today when it comes to composability. But the good news is that it's totally possible, technically speaking, for them to join the party and grow the network effects. And secondly, there is an incentive for them to join the party because they get to access this shared liquidity and this overall traffic that will ultimately grow their bottom line through fees, transaction fees.
And I think that's a great segue to my next question, which is kind of related to the title of this fireside chat, which is beyond settlement. And so, I think initially it does seem like Ethereum can provide settlement for these L2s. But I know you've been a champion of providing additional functionality. In part, I think, just to make the lives of these L2s easier and maybe to make it easier for people to launch L2s and maybe L1s to transition, but also in part perhaps to provide even greater value to ETH, the asset. And so I'm kind of curious, where you envision kind of Ethereum going on this front. Like, what can it do beyond just offering settlement to L2s?
Right. So with shared settlement, we get shared security, and we also get shared assets that can communicate and compose with each other asynchronously, which is already pretty good for things like simple payments. But one of the things that we've discovered empirically in the blockchain space is that no blockchain platform has really found product market fit with developers if they are asynchronous. So you look at Cosmos, Internet Computer, Near, Ton, And all the other ones that have tried this asynchronous model is just a real pain from a perspective of developers. And so right now we're in this kind of awkward puberty phase of adolescence for Ethereum, where we've introduced asynchrony across the so-called clusters. So we have the optimism cluster, we have the elastic chain cluster, and all sorts of other clusters. And I think what's going to happen is that even within those clusters, we've lost synchronous composability. But I think as a first step, we're going to get the synchronous composability within the clusters, and then ultimately across the clusters. Now, in order to get this first-class type of composability that has made Ethereum successful and made Solana extremely successful, we're going to need two things. Number one, we need this piece of technology called real-time proving. And this can be done totally trustlessly using snarks, but we're not there just yet today. Next year, we'll be there. So we need to be patient and wait a few months to actually get the real-time
Next
proving.
year is really soon.
Next year is pretty soon, yeah, in the grand scheme of things. But if you're really, really desperate to do it today, then you can use TEs as a training wheel for real-time proving. And then there's this other thing that you need for synchronous composability, which is shared sequencing. And that is much harder because it is a social coordination problem, and there's some amount of ego involved, there's incentives involved, and there's also like
MEV
basic
involved?
MEV that's tied into the incentives, and there's also just a lack of understanding in general as to what it means to share a sequencer. And so what I've been trying to do is basically to try and find a candidate shared sequencer for all of Ethereum that goes way beyond the clusters that we have. And as far as I can tell, there's only one candidate that fits the bill. There's only one shared sequencer which is credibly neutral, and that is Ethereum itself. And the sequencer is called the based sequencer. And why is credible neutrality extremely important? Well, take two clusters, for example, the optimism and the arbitrum cluster. Are they ever going to merge directly? Well, probably not. Again, because of these egos and these, because there's different tokens, different brands, different security assumptions. But is it plausible that optimism joins the Ethereum sequencer and arbitrum joins the Ethereum sequencer? Yes, that is plausible. And so in some sense, Ethereum potentially could be this neutral playing ground to unlock a lot of network effects that are currently trapped within the silos of non-composable, non-synchronously composable rollups and L2s.
Interesting. Okay, so you touched upon two things. So we know that Ethereum can provide settlement. Now you're saying also Ethereum can provide sequencing through base sequencing. And then you also touched upon real-time proving, which I think is kind of the third thing, that maybe not the proving part, but at least the verification of those proofs. And I think in order to get that composability that you talked about, that synchronous composability, you need to then be kind of verifying those proofs while you're sequencing, right? Can you talk a little bit more about that?
Yeah, so the way that it works is that you have one master proposer who has monopoly rights for multiple rollups at the same time, so within a single slot. And what they do is they're going to craft their block to have interleaving transactions that send assets in and out or make calls in and out of these rollups. And then at the very end, they have kind of a master proof that proves that like all of these interactions across the rollups that don't trust each other are indeed correct.
Yeah, so you're effectively leveraging proposer-builder separation. These block builders are constructing these blocks with all of these different transactions, and then they're creating a proof that these transactions actually are atomically executing, right? So they're not just both included in the block, they're guaranteed to execute. And when you have that, then you can kind of guarantee atomicity.
Exactly. So let's say, for example, you want to make a big market purchase of some token, and you have ETH. And what we'll do is we'll like route the trade through all the liquidity within all of the L2s, and you basically get aggregators across L2s. Like, why don't we have matcha or 1inch across L2s is because of asynchrony. Asynchrony sucks. But the good news is we can have aggregators across these L2s once we have real-time proving and shared sequencing.
It's fascinating. And so, yeah, there'll be a future, hopefully not too soon, maybe next year. We'll have Uma from Succinct actually on stage after lunch, so we can also ask her how close we are to SP1 real-time proving. But hopefully by next year, we'll be able to have this kind of synchronicity. The one question that I think still in my mind is still kind of uncertain is, what are these proving systems proving? Is each L2 going to have their own proof, or are we going to have kind of a native kind of Ethereum maintained proof system, or not proof system, but L2 implementation, and everyone who wants to have this synchronicity has to follow that same implementation?
Yeah, so one mental model for a based rollup is basically a layer 1 contract that has much lower gas fees, maybe 2 orders of magnitude lower gas fees. And so you should think of the different contracts as not having to trust each other, and they can be extremely non-homogeneous. So you have searchers, for example, that will do arbitrage between Uniswap and Curve. Like, these are completely different virtual machines, completely different smart contracts with different APIs, and yet you have abstractors like the matchers and the Uniswaps and the searchers who are able to understand the language of each and provide synchronous composability among these smart contracts. And the same thing will happen with base rollups. Even if you have an EVM based rollup or RISC-V based rollup or MIPS or Cairo, whatever it is, all of the differences in virtual machines can ultimately be abstracted. The fundamental capacity that you want is to be able to make a call from one rollup to another and immediately get an answer and immediately be able to withdraw assets in and out of these chains. Now, we can't have too many proofs that settle on chain. So one of the things that needs to happen at some point is this notion of shared proof verification. So if you happen to have some rollups, let's say 10 of them, that all have the exact same virtual machine and proof system, well, you can aggregate the proofs into one single proof, and you don't lose any security in that process. Now, in addition to doing the shared proving, one of the things you can also do in the future, project yourself several years into the future, is shared proving with Ethereum itself. Because one of the big goals for the Ethereum L1 is to snarkify the L1 EVM and to add a precompile that exposes this ZK EVM within the EVM. So if you are an EVM equivalent rollup, you can just ditch your custom circuit or your custom fraud proof for this one line of code. And the advantage of using that precompile is that there are no bugs by construction. It's an exact copy of the L1 because that's what the validators will be verifying. And when the L1 EVM changes, for example, a new opcode is introduced, you don't need governance to be able to update the rules of your circuit to match the L1 change. And so that means that we can have rollups where at least the VM portion is fully immutable, governance-free, and bug-free by construction.
So that's kind of the native rollup kind of idea. And how soon do you think that precompile will happen? How certain do you think that it's going to happen?
Well, I think it's just technology, and I think it is not controversial in terms of when it can happen. The first step is to snarkify in real time the L1 EVM with client diversity. So just like today we have 5 execution clients, we would need the equivalent of 5 ZK EVM so that if there's a bug in 1 or 2 of them, it doesn't take down Ethereum. And we also need this real-time property, which basically says that the proof latency needs to be within 1 slot. So for example, within 12 seconds. And I think we're going to get that next year. And then there's going to be a whole process of someone having to champion this, to write an EIP, to go through the governance process, and it's going to take maybe 2 or 3 years altogether, maybe 4 or 5 years. I guess it's going to depend on market appetite. One of the things that might accelerate this opcode is if a massive rollup gets hacked. Let's say an EVM equivalent rollup with $10 billion in it or $100 billion in it, remove the training wheels and boom, they get hacked. That would be a huge motivation for this precompile to remove this attack vector.
Well, let's hope we don't have that motivation. That sounds terrifying. And so you mentioned kind of 5 or so implementations. So does that mean that, like, if you're an existing L1 that maybe isn't even EVM compatible, and you're thinking about transitioning to being an L2, and you're excited about settlement and all of the benefits that you get from Ethereum by using it for settlement, but you're also excited about this composability, does that mean that it might be hard for folks to compose because they won't fit into these kind of 5 canonical proof systems, or is there a way for them to be involved as well?
Yeah, so as I mentioned previously, if you have a completely different virtual machine, then you still can have this synchronous composability, first-class composability. And the reason is that any difference in virtual machine can be abstracted away. It's just a different call with a different API endpoint. It's no big deal. I mean, it is more work for the searchers, and when you talk to searchers, they'll tell you that they'll pull their hair out trying to arbitrage, Curve and Uniswap because it's a completely different model. But we have more and more tooling to abstract away this for developers. Now, you do get certain superpowers by using the precompile. One of them being that you're bug-free by construction. But the good news is that there's another way to be bug-free, which is to have formal verification. So imagine that your Starkware with Cairo. It's a very, very simple virtual machine, and they've actually formally proven big chunks of it. And so you could foresee a point in time where they're sufficiently comfortable with the security of the implementation, and then they just completely freeze it by removing the ability for governance to change the rules of the virtual machine. Now, one thing I do want to highlight is that the way that we would snarkify the EVM is using ZK-VMs, and it turns out that the de facto industry standard seems to be RISC-V. So I did the count, there's 7 different teams, 7 different ZK-VM teams.
Oh, 7.
Yeah, so there's RISC-0, SP1, there's Nexus, there's Scroll in collaboration with PSC, there's 3 others. And basically, if this trend continues, then what could happen is that the L1 precompile could expose an even lower level virtual machine. It could expose RISC-V instead of exposing the EVM, and then the EVM would just be, just RISC-V bytecode. And so that would be even more powerful. And one of the cool things here is that it would allow us to have a very credibly neutral and straightforward gas schedule, which would be 1 gas equal to 1 cycle of a RISC-V CPU. So there would be no more bike shedding on the gas schedule.
Wow, really interesting. Cool. I think we're getting close to time. Maybe just to end with more of a closing question. So, with Celo transitioning to becoming an L2, we just announced kind of mid-January as the date when that's going to happen. I guess as you look beyond Celo to other L1s who might want to transition, what would you say to them? What would you recommend?
I mean, my thesis for several years now has been that it's winner take most in terms of the ecosystems because of these strong network effects around shared security.
A graveyard of microphones.
Shared security, shared composability, and if my thesis is correct that it is winner take most, then entrepreneurs and builders and chains will have no choice but to join the winner take most. I mean, right now there's a little bit of a battle, I guess, between Bitcoin and Ethereum because in order to be like the unquestionably like secure platform for shared security, you need to have very, very large amounts of economic security. And basically the strategy of Bitcoin is to start building L2s there and grow network effects. And the strategy of Ethereum is basically to flip Bitcoin and be the unquestionably kind of largest ecosystem. So we'll see how that battle plays out. I know where I'm placing my bets, but ultimately I think it will be very, very difficult for the long tail of L1s to survive.
Cool. Well, that might be a good place to end. Do we have any time for an audience question? Perfect. We have one question. Anybody have a question for Justin? Joe.
Hey guys. So it sounds like you're assuming that there's going to be protocol enforcement on reduced gas fees for the based shared sequencer. It's a smart contract. Is that correct? What are you thinking about in terms of mechanism?
So sequencing is all about composability and synchrony, and it doesn't really affect the fees. If we want to talk about the fees, we need to look at the virtual machines, and this is where the native rollup, previously known as enshrined rollups, come into play. And there's two very, very exciting things from a scalability standpoint of execution. The first one is that once we've snarkified the EVM, we can dramatically increase the gas limit. Think 10x, 100x. And the reason is that right now, we have the gas limit to protect the validators. They receive a block, they naively re-execute it, and it can't take more than a second or so to validate this block. And so if we were to 100x the gas limit, then it would take 100 seconds to verify blocks potentially. When you've snarkified the EVM, it will always take on the order of 1 millisecond to verify the blocks, meaning that we can dramatically increase the gas limit and still have safe decentralization. So that is vertical scaling. The problem is that the EVM has fundamental constraints. It is, there's like bottlenecks, for example, in updating the state root. So it will only be able to process, X transactions per second, and there's going to be a hard cap dictated by the laws of physics. It might be 1 million transactions per second if we really squeeze the engineering out of the EVM. And then we're going to be forced to scale horizontally, and this is where this notion of programmable execution sharding comes in. So you'll be able to take this L1 EVM opcode and instantiate as many instances of the EVM as you want. And this is it's very reminiscent of execution sharding, but it's so much more exciting because it's programmable. So what does programmability give us? Number one, it means that instead of having a fixed number of shards, for example, 64 or 1024, we can have as many as we want. And secondly, they're configurable. So you can have configurable sequencing, configurable governance, and public goods funding, and gas tokens. And so we would keep the richness and the diversity of these ecosystems while hardening the virtual machine, which is purely technology that should be commoditized and extremely secure and shouldn't really be a competitive edge for those rollups.
Awesome. Well, with that, let's give Justin one more round of applause. Thank you.